Hello learners, today we are going to talk of a new topic on chemical bonding and structure. In this new topic, we will look at the various types of bonds and how we get into the aspect of bonding and the various types of structures and how we get into the process of structuring of molecules or elements or atoms. So, on an introduction of what is a chemical bond. What is a chemical bond? A bond that is chemical results from the attraction of electrons of the outermost shell by the nucleus. That is, remember a recap from our previous classes, we said that in the nucleus we have the protons that are positively charged and the neutrons that have no charge. And usually the protons that make the nucleus positively charged are the ones that attract electrons. The attraction between the positive nucleus and the negative electrons is what results to a chemical bond. Usually when a chemical bond occurs, both atoms that are losing or gaining electrons or getting attracted to each other are looking for a stable state, what we call as an octet space, an octet state. Remember when we were looking at the various groups in the periodic table, we talked of the group 18 elements, what we called as the noble gases, and we said they are in a stable state because the outermost shell already is full of electrons. It cannot lose, neither can it gain. That is what all other elements are looking for when they are being engaged in a chemical bond. In other words, the protons in one nucleus are attracted to the electrons of another atom. It is this ability to attract the electrons that we measure, and we call it electronegativity. We will look at electronegativity at a later stage in this class. However, you should note that electronegativity is the measure of how much or how strong an atom can attract electrons during a chemical bond. It could be strong or it could be weaker depending on the position of the element on the periodic table. When we look at chemical bonding, what is involved in a chemical bonding process are valence electrons. Valence electrons are the electrons that are found in the outermost shell of any atom or any element. These usually include the s and p electrons of the main group of elements we discussed when we were looking at the periodic table. The s and p electrons are responsible for the chemical properties of various atoms and the results of any chemical bond, and they participate in chemical reactions. They can be transferred or they can be shared, as we will see in subsequent classes. For instance, in the case of sodium has got 2 electrons in its innermost shell. Then it has got 8 electrons in the second shell, and in the last one it has got 1 electron. For it to be engaged in a chemical bond, remembering that it is in group 1, it needs to lose its electrons so that it can form a sodium cation. This valence electron that is found in the third energy level is what is transferred to another element so that sodium can engage in a chemical bond. As I have mentioned that every time the elements are engaging in a chemical reaction, the aim is to meet the octet rule, and the octet rule is a tendency of atoms to seek the 8 electrons in their outermost shell, what we are calling a stable state. Remember what I have said about the noble gases is that they have already met the octet rule. They have 8 electrons in their outermost shell. They cannot lose or nor can they gain. Therefore, they are in a stable state. Any other element that does not meet the requirement of the octet rule is seeking to do so by either losing, gaining, or sharing the electrons. And this is what we will see when we are talking about chemical reactions or chemical bonding. It involves either the gaining, the losing, or the sharing of the various electrons. And the aim to meet the octet rule is for a certain element to be stable. However, when you look at the octet rule, it applies for all elements with the exception of helium and hydrogen. The helium and hydrogen do not engage in the octet rule because their atomic number is 2. Therefore, they are only seeking to fill in the first shell that contains 2 electrons. There are two major types of chemical bonding. These include the ionic bonding that forms ionic compounds through the transfer of electrons and the covalent bonding that forms molecules via the sharing of electrons. And I repeat, there are two major types of chemical bonds or chemical bonding processes. The ionic bonding that forms ionic compounds through the transfer of electrons and the covalent bonding that forms molecules via the sharing of electrons. We will look at the details of each one of these in the subsequent slides. However, I want us to look at one of the minor types of bonds, which we call as the metallic bonding. This one usually occurs between like atoms of a metal in their free state. When I talk of their free state, is that they have already lost their outermost, they have already transferred, or they are already in their cation state. They have already transferred their outermost electron. Usually the valence electrons, those that are in the outermost shell, are mobile. Therefore, they move freely among all metal atoms, and this results to a positive state such that there are different metals with a different nucleus that is positively charged. However, there is a sea of electrons that is surrounding these electrons from the various metals. The characteristics of such metals is that such metals and such metallic bondings is that they have got high melting points and high temperatures. They are ductile, they are malleable, and they are shiny. When you look at these characteristics, when we were looking at the periodic table, we said that the group 1 elements, the alkali earth metals and the alkaline metals, are the ones that have got these characteristics. They are very reactive, they have a high melting point, they have high temperatures, they are ductile, malleable, and shiny. They are also hard substances and good conductors of heat and electricity. Therefore, it is at this stage we would say that most metallic bonding processes involve the group 1 and the group 2 elements. And it is the mobile electrons within these group 1 and group 2 elements that enable them to conduct electricity. So let us look at the first kind of bonding, which we are calling as the ionic bonding. Usually, the ionic bonding is as a result of the transfer of electrons in the outermost shell from the outermost shell of an element. That is what we are calling as the valence shell electrons to another atom. The result is what we call as ionic compounds. Remember, we discussed this when we were looking at the various fundamentals of an atom. What results is an anionic compound. And remember, we are saying ionic bonding is made of ions and not molecules. Remember the difference between ions and molecules. Ionic compounds are also known as crystals or salts. The process of ionic bonding is also known as electrovalent bonding. Ionic bonding usually is always formed between a metal and a non-metal. And in this case, the metal is the one that loses an electron and transfers it to a nonmetal. Therefore, a metal loses its electron and transfers it to a nonmetal to gain its ionic form. The metal becomes a cation while the nonmetal becomes an anion. When you look at the periodic table, so that we can see which are the metals and which are the nonmetals or how the reaction occurs, is as you will see, these group 1 elements, all of them have got a positive cation charge of 1. Therefore, they only have the capacity to lose 1 electron. On the other hand, group 2 elements have the capacity to lose 2 electrons to a nonmetal, that is, to transfer 2 electrons. That hence, they have got a positive charge of 2. When you look at the transition metals, most of them have got the ability to lose 2 electrons, meaning that their outermost shell has got 2 electrons. When you look at the case of group 3 elements where we have got aluminium, aluminium has got the capacity to lose 3 electrons from its outermost shell and transfer them to a nonmetal. When you look at the other case of the nonmetals, like in the case of the group 7 elements, what we call as the halogens, fluorine, chlorine, and bromide have got the ability to gain 1 electron, that is, to be transferred 1 electron from a metal so that they can get their ionic state. In this case, an ionic charge of 1, -1. Therefore, for a chemical bond to occur, the metals have got to lose their electrons and transfer them to nonmetals. Let us look at a case example of the formation of sodium chloride, or what we commonly refer to as salt. Sodium has got 1 electron in the outermost shell, and chlorine has got 7 in its outermost shell. Therefore, for a reaction to occur, sodium will be transformed in its ionic form by losing 1 of its electrons and transferring it to chloride. In this case, sodium will remain with only 2 energy levels, while chloride will be filled in its outermost energy level. This is what we are calling the trying to gain the octet state. And these are the processes that are involved. Sodium will transfer 1 of its electrons to chloride so that it becomes sodium cation, while chlorine becomes chloride anion. And the result is what we are calling a kind of a salt or a crystal, what we are calling as sodium chloride. The same case occurs for magnesium. Magnesium is in group 2. Remember that in its outermost shell, it has got 2 electrons and it needs to transfer them to any other element so that it can be engaged into a reaction. In the case of fluorine, it has got it has got 7 electrons in its outermost shell. Therefore, for a reaction to occur, magnesium must occur in a chemical reaction to form a salt using 2 molecules of fluorine. That is, in one of the molecules, it will lose 1 of its valence electron, and in the other, it will lose the other remaining valence electron to form what we are calling as magnesium fluoride, a kind of a salt. It is the same case for calcium chloride. Being in group 2, it requires 2 electrons. It requires to transfer 2 of its electrons to a nonmetal. In this case, it is chloride. Chloride has got 7 electrons in its outermost shell. Therefore, for a chemical reaction to occur between calcium and chloride, we require 1 atom of calcium and 2 atoms of chloride for the reaction to get to an octet state. What are the properties of these we are calling ionic compounds or salts, or what we are referring to simply as crystals? Usually they are hard. They are hard solids at room temperature. They have got high melting points and they are non-conductors of electricity in their solid state. However, they are good conductors of heat in their liquid state or once dissolved in water, what we are calling as the aqueous form, what we are simply referring to as AQ, the aqueous form. In their aqueous form, ionic compounds are good conductors of electricity, that is, once dissolved in water. They are packaged into lattices where opposite charges are attracting one another, as we said in previous classes. Ionic, ionic bonds are also omnidirectional. By omnidirectional is that they can be arranged in every direction and they can be dissociated into free ions. By being dissociated in free ions, this only occurs when they are in their liquid form or when they are dissolved in water. What I am referring to here, that they exist in free cations of potassium, for instance, in the case of potassium chloride. They exist in free cations of potassium and anions of chloride, and they are able to move around in an omnidirectional omnidirectional orientation. So I have here are some questions you can attempt to see how we can represent the chemical ionic bonds of magnesium fluoride, potassium fluoride, and lithium chloride and calcium oxide. Remember, for you to be able to represent these ionic compounds to represent their ionic compounds, you have to know what is a valence, how many valence electrons does magnesium and does fluoride have? How many does potassium fluoride or lithium chloride or calcium oxide has? How many electrons must it gain or must it lose to get to an octet state? That is the only way you will be able to represent this. For your exercise, you need to show or you need to do it. When ionic compounds combine, their respective charges must balance. And this we had mentioned when we were looking at the fundamentals of an ion and an atom, that once sodium chloride or magnesium chloride becomes an ionic compound, the charges of magnesium and the charges of magnesium and the charges of chloride must cancel out. That is why we are saying in the case of magnesium that has got 2 electrons to lose in its ionic form must bond with 2 chlorides because chloride has only 1 charge. So for the charges to balance out, we require 2 atoms of chloride in their ionic state. Here are some questions I prepared for you to understand the previous concept on the charges cancelling each other during the process of ionic bond formation. When you look at this table, when you look at it carefully, when you look at an element like hydrogen, hydrogen has got a charge of 1. Therefore, it requires to transfer the 1 electron that it has to gain a stable state. However, we will see that as we saw in the beginning of this class, is that for one to be in an octet state, for an element to be in an octet state, it has got to have 8 electrons with the exception of helium and hydrogen that are known as duets. That is, they require 2 electrons to get a stable state. Therefore, in this case, hydrogen must lose or share the 1 electron to get to a stable state. Sodium, on the other hand, must transfer the 1 electron in its outermost shell to get a stable state. Magnesium, barium, calcium, zinc, cadmium, mercury, copper, lead, and iron, all of them have got a charge of positive 2. They must transfer the 2 electrons to get a stable state. Aluminium and iron 3, on the other hand, also require to lose 3 electrons. Remember what we said about the difference of iron 2 and iron 3 in our subsequent classes. Therefore, elements with a charge, a cationic charge of 3 require to lose the 3 electrons to get to an octet state. When we look at the anions, those that are nonmetals, is that those of group with a negative charge require to gain 1 electron so that they can get to a stable state. Those with a negative charge of 2, such as oxide, sulfide, sulfate, sulfite, and carbonate, require to gain 2 electrons so that they can engage in a chemical reaction, in a chemical ionic reaction. Those with a negative charge of 3, such as phosphide and phosphate, require to gain 3 electrons for them to become stable, or what we are referring to as an octet state. Using this knowledge, using this table, please, can you write the formulas of copper 1 oxide, zinc phosphate, on 3 chloride, and lead bromide for your practice? Thank you.